two circles are S is equal to x square plus y square plus 2gx plus 2fy plus c. Yes, g1 f1 c1 is equal to 0. So suppose is the first equation of circle. Second equation s dash is equal to x square plus y square plus 2g2x plus 2f2y plus c2 is equal to 0. So we assume here two circle x square plus y square plus 2g1x 2f1y plus c1 is equal to 0. Second circle x square plus y square 2g2x 2f2y plus c2 equal to 0. Okay. So we need to find angle between these two circles. Suppose this is the first circle. This is second circle. Suppose we can give the name S is equal to 0. This one S dash is equal to 0. Suppose this is center of the circle C1, center C2. Now here we draw their common tangent. So this is common tangent to the circle. Again this is a common tangent to this circle. Suppose point of intersection of these two circles is P and this is Q. Now these tangents are cutting this line. Joining center is at A and B. Now if we write here radius of first circle, we assume this is radius of first circle R1. Now this is radius of second circle, that is R2. We assume here distance between centers C1 C2. Let C1 C2 is equal to how much? D. So C1 C2 is distance between these two centers. Now what we want? We want angle between their common tangent. So we want this theta. Suppose this angle is theta. So how to find this theta? Theta is what? This is angle between their common tangents. So how to write this theta? See here. If you write here angle C1 P C1 P B. So see here this is the radius of first circle and this is what? Tangent. So this is a tangent. So this angle how much? This is equal to 90 degree. Same way if you see here this is the radius and this is the tangent. So if you write here is equal to angle C2PA. This also what? 90. Now we write here angle C1PA. C1PA. C1PA is equal to 90 minus theta. See here this total angle is 90 degree. So this is what? 90 minus theta. Similarly, we write angle C2PB. C2PB is also what? 90 minus theta. Now we want this angle theta. So if you see here this total angle C1PC2. So total angle C1PC2. So how much this one? We had C1PA plus APB plus PC2B. So we can add all the angle. So C1PA plus angle PAB plus angle PBC2. We can add all the angles. So how much get here? So you can put everything from here. So C1PA that is equal to 90 minus theta plus PAB. So what is PAB? PAB that is theta plus angle PBC2. PBC2 that is 90 minus theta. So here 90 plus 90 is 180. Theta and theta cancel out. So what do you get here? 180 minus theta. So this is how much? C1 PC2. So we get here angle C1 PC2 is what? 180 minus theta. Now we see here this triangle C1 PC2. So here we know the R1 here, we know R2, we know C1 C2. So up to here. Okay, now see triangle here C1 PC2. So you can draw the triangle. This is P, this C1 C2. P C1 C2. Now where you know this is what? R1, this is R2. Okay, and this total angle is what? 180 minus theta. See here C1A, C1P, C2. Now this is D. We assume here C1 C2 how much? Is equal to D, distance between centers. So now we study in solution of triangle cosine rule. We study cosine rule. So in triangle PC1 C2 use cosine rule. So what is cosine rule? So here we write cos 180 minus theta is equal to, sir, what? R1 square plus R2 square minus D square divided 2R1 R2. So you study in cosine rule. 180 minus theta equal to R1 square, R2 square minus D square by 2R1 R2. So here we want, in definition we told, we want acute angle. So acute angle means we know this value may be positive, it may be negative. So that's why we take here mode. So cos theta equal to R1 square, R2 square minus D square by 2R1 R2. We are taking mode. Why we are taking mode? Because we want acute angle. For acute angle. Okay, so here we know the two circles. So we can find R1 as well as we find R2, and we know C1, C2, we find D. So this for acute angle between two circles. Now we check condition for orthogonal. When you said these two circles are cutting orthogonally, orthogonal means perpendicular. So here you write heading condition for orthogonality. So when you said two circles are orthogonal, so orthogonal means these two circles will cut each other at perpendicular. Or we can say angle between their common tangent is 90 degree. So here we write orthogonality. It means theta is equal to what? 90 degree. And what is theta? Angle between their common tangents at their point of intersection. Theta is angle between their common tangent at their point of intersection. So here from this equation we know cos theta equal to what? R1 square, R2 square minus D square by 2R1 R2. So cos 90 is equal to what? R1 square, R2 square minus D square by 2R1 R2. So cos 90 is 0. So what do you get here? R1 square, R2 square is equal to D square. So this is condition for orthogonality for two given circles. Okay, now we find relation between coefficients. Consider two circles, that is, we assume already S is what? X square, Y square plus 2g1x, 2f1y plus c1 is equal to 0. This is S. Now second circle we assume S dash, that is x square, y square plus 2g2x to f2y plus c2 is equal to 0. So here we can find what is r1. So r1 is equal to under root g1 square f1 square minus c1. Now what is r2? Under root g2 square f2 square minus c2. Now what is center of our circle? C1. That is minus g1 comma minus f1. What is c2? Minus g2 comma minus f2. So here we can find what? r1 square, r2 square and d square. What is d? D is c1 c2. Distance between centers. Okay, so now this value you put in this formula. So what is r1 square? g1 square f1 square minus c1, that is r1 square, plus g2 square f2 square minus c2 is equal to. Now find c1 c2. So here we know center, here we know this center. So how much to get here? g1 minus g2 whole square plus f1 minus f2 whole square. Now we can simplify this one. So what to get here? g1 square f1 square plus c1, here minus c1, plus g2 square f2 square minus c2 is equal to, now a minus b whole square. So g1 square plus g2 square minus 2 g1 g2 plus f1 square f2 square minus 2 f1 f2. Now here g1 square f1 square g2 square f2 square, these terms are cancel out here. So finally what you get? Condition for orthogonality. So we write here finally relation between coefficient. Condition for orthogonality is 2 g1 g2, see this one, 2 g1 g2 plus 2 f1 f2, we are taking these two terms this side, is equal to c1 plus c2. So this is relation between coefficient for condition for orthogonality. Either we use this condition or you can use direct this condition. Okay, thank you.